welcome to 4.3 Part 1, Reference Angles. So we briefly mentioned reference angles yesterday when we looked at our special triangles. However, these were all reference angles from a special triangle. And today we're going to be looking at reference angles when we're dealing with radians that are not one of our special angles. We're also going to be looking at how to use your calculator when you're trying to calculate some different values when you can't use a special triangle. And we're going to be looking at how to figure out what quadrant to draw your angles in if it's not one of these main ones that we've already taken a look at using our unit circle. So first, we're going to draw each angle below and then evaluate using a calculator. Okay, so you do need a scientific calculator if you don't have one. A phone calculator will work fine, but most people will not allow you to use one of those on something like a test or an exam. So having a good scientific calculator you know how to use is really important. So first, sine of 60 degrees and sine of 120 degrees. So 60 degrees we know is in quadrant 1. Okay. And if I want to find sine of 60 degrees using a calculator, we need to make sure that our calculator is in degrees mode. And we're literally just going to type in the sin button and then 60 degrees equals. Some calculators, you might have to type the number first and then the sign button. So you do need to make sure you know how to use your calculator. And if we do that, we should get 0.866. The next one is 120 degrees, which is in quadrant 2. 120 degrees would go over here. And we're going to do the same thing, sine of 120 degrees in our calculator, and we should get the same answer, 0.866. And the reason for that is because if I draw a little triangle in both these spots, my triangle I have over here on the right looks like this, and my triangle over here on the left also has 60 degrees in this corner, 90 degrees here. So these are actually the same triangle, just reflected across my axis. Now, because sine is opposite over hypotenuse, my opposite here is y. My hypotenuse is the radius of whatever circle this lies on, where this arm is swinging around the outside. For my other triangle, my opposite is my y, and my radius is my r. The difference between these two triangles is actually the x on the bottom, right? The x on the right-hand triangle is positive. The x on the left-hand triangle is negative, but we don't use x when we're dealing with sine. The y's for both of these and the r's for both of these triangles would actually be the same. And this is why our sine value is the same. We have the same angle in that bottom corner, and both of these y's and r's are positive. My sine value should be the same positive number for both. Now, when you're calculating this in your calculator, you need to make sure that your calculator is in degrees mode. Okay. Most calculators won't actually say the word degrees. Most will use DEG or a D. Okay. If it's not on the main buttons of your calculator, you might have to look through the setup menu or the mode menu to see where it is. And this is why having a calculator you know how to use is very important. For the next one, we're going to look at tangent, and our angles are in radians. So tangent of pi over 3 is in the first quadrant. Okay. And if I plug this into my calculator, we now need to make sure we are in radians mode. Okay. Your calculators will all work differently. Some of you will need to put brackets around this when you plug it in. Some of you will need to do pi over 3 first and then type the tan button. You should be getting 1.73. If you're not, double check that you're in the right mode, double check you're not typing tan of pi and then dividing that answer by 3. You need to be doing tan of pi over 3. The next one is 5 pi over 3. So 5 pi over 3 is actually in quadrant 4. And that's because 3 pi over 3 would be a half circle. 6 pi over 3 would be a full circle. 5 pi over 3 would go here. So if I do tan of 5 pi over 3, again, you might need brackets. You're not doing tan of 5 and then multiplying that answer by pi and then dividing that by 3. For some calculators, if you just type it in with no brackets, that's what it will do. Okay, so we really need to make sure you're operating your calculator properly. We should get negative 1.73. And the reason we're not getting the same answer here is if I look at these triangles, I have pi over 3 in my bottom corner for both of these. I have my y value, my r value, and my x value for my top triangle. My bottom triangle, I have my x, my r, but my y is negative. Tangent is opposite over adjacent. My opposite here would be y, my adjacent would be x. But for the bottom triangle, my opposite is negative y, my adjacent is x. And that's why the answer is negative instead of positive. Okay. So for this one, we need to make sure calculator is in radians mode. Again, most of them won't say the word radians. It'll either say RAD for radians or just an R. So to reduce the complexity of angles, reference angles are usually used for trigonometric calculations. So for any angle, theta in standard position, we can find a reference angle. Okay. The reference angle is always between the terminal arm, so that's the arm that's swinging around depending on where your angle is, and the x-axis, the nearest x-axis. So for any angle in standard position, its reference angle is the angle between terminal arm and the nearest x-axis. So before we start actually figuring out values for tan, sine, cosine, we need to be comfortable with where do these angles go and which quadrants are things labeled in, what are the reference angles, and we need to be comfortable with our 4 quadrants. Okay? So I find it helpful to label my axes with my radians. So for example, my positive x-axis is 0 or 2 pi. My negative x-axis is pi radians. My positive y-axis is pi over 2. And my negative y-axis is 3 pi over 2. Now, some people find it helpful to change these to have a common denominator with the radian angle they've been given. So our first one, for example, is over 7. Okay, so pi over 2, this would be 3.5 over 7 pi, which isn't great. So this could also be 7 pi over 14. And then the pi would be 7 pi over pi, or over 7, sorry, or 14 pi over 14. 3 pi over 2, this would be 10.5 pi over 7, or this would be 21 pi over 14. And 2 pi would be 28 pi over 14. Because my common denominator between the red values and the value I was given would be 14. So this is the same as saying 4 pi over 14. Okay? And then this can help me figure out what quadrant to put this in. So this is not necessary, but some people find this helpful to be able to visualize where your angle is going to go. I like to think of it as, okay, well, I know that 7 pi over 7 would be my positive or my negative x-axis where my pi is. And I know that my positive y-axis is half pi, which half of 7 is 3.5. Well, 2 is smaller than 3.5, so my angle must be in quadrant 1 somewhere. So for my next one, I know that 5 pi over 5 is the same as pi. And if I'm trying to graph 6 pi over 5, I know that I'm going farther than that, but I'm not going far enough to have 1.5. 1.5 pi's would have been 7.5 over 5, right? This would be 7.5 pi over 5 is equal to 3 pi over 2. So I'm not going that far. I'm only at 6. So I'd be somewhere in here. My last one, negative 8 pi over 3. This means I'm going in the opposite direction. I'm going clockwise. Okay. So I'm going this direction. Okay. Now I know that this would be negative pi, which is negative 3 pi over 3. This would be, if I'd gone a whole circle, this is negative 2 pi, which is negative 6 pi over 3. I have to keep going. If I keep going to the next one, if I went all the way over to here, this would be negative, the same as doing negative 3 pi, which is negative 9 pi over 3. And I didn't go that far. I only went 8. So I'm doing one full rotation. And then I'm keep going not quite to 1.5 rotations. Okay. So if it helps you, make common denominators like that first example. But you can also use the half circles to figure out how far you're going. All right, so we're going to try some questions where we're going to draw some angles. We've got some in degrees, some in radians. We're going to figure out what quadrant we're in and state our reference angles. So 120 degrees, hopefully we know by now, is in quadrant 3, or sorry, quadrant 2. And our reference angle, remember, is between our terminal arm and our closest x-axis. So our reference angle is in here. Now, since this is 180 degrees on that x-axis, that means this reference angle must be 60 degrees. For the next one, we've got pi over 6. Pi over 6 is in quadrant 1. And anything in quadrant 1, the reference angle is itself, because the measure of your terminal arm to your closest x-axis is the same as the measure of the angle. So our reference angle here is just the angle itself. Okay. Now the next one tends to trip people up because they see the number 3.5. So they automatically assume it doesn't have a pi, therefore it must be degrees, but there is no degrees sign. This is in radians. Okay. So 3.5 radians. We want to know, where does that go? Well, I know that 0 radians is here. Pi over 2 radians is here. Pi radians, 3 pi over 2, and then back to 2 pi. Now, my question doesn't have a pi in it. So it's just a number. But I can turn all these ones with pi's into numbers. So I know that pi is 3.14 radians. 2 pi is 6.28 radians. 3 pi over 2 is going to be about 4.5. And pi over 2 is going to be about 1.5. So if I want to go 3.5 radians, I'm going just past 3.14. So my 3.5 radians would be in here. Okay. Now my reference angle is this little extra distance that I traveled here. That's where my reference angle would go. So my reference angle is whatever extra I had to travel to get from my pi along the x-axis to my terminal arm at the 3.5. So this would be 3.5 minus pi, that little extra distance that I traveled, and that would be 0.36 radians. So notice I'm not writing radians for B and C. No units implies radians when we're talking about angles. You'd like to pause here and try the next three on your own. If you're finding this straightforward, that would be a good idea. Otherwise, you're welcome to just continue along as examples. So the next one, 310 degrees, is in quadrant 4. And our measurement would go here. Our reference angle is between the terminal arm and the closest x-axis. And that extra distance I would have to travel to get from my terminal arm to my x-axis would be 50 degrees. Next one is negative 5 pi over 4. This means I'm traveling in the opposite direction here. 4 pi over 4 would be a half circle, but I went farther than that. I went 5 pi over 4, so I would be here in quadrant 2. My reference angle is between my terminal arm and my closest x-axis, which would be right here. So I'm looking at how much further did I travel past that x-axis. That x-axis would be negative 4 pi over 4. So I traveled further by pi over 4. Now, please note that when we're looking at reference angles, we always write these as a positive angle. It's the distance between the x-axis and your terminal arm. So even though our theta, our original angle here, is a negative angle, that just indicates the direction in which we are traveling. The actual reference angle is the distance between the terminal arm and the x-axis. That distance here is pi over 4. Last one, 472. So we know we're going around the circle more than once because once is 360. So if I go around 360, the question is how much further do I need? This is the same as saying 360 plus 112, and 112 would be in quadrant 2. Our reference angle would be below that between the terminal arm and our x-axis. And that distance for that reference angle would be the same as saying 180 minus 112, because the 112 was that extra bit. Or how far do I need to go until I get to that x-axis there? And that would be 68 degrees. Now, if you have the PDF of this document, there are some practice questions on this next page. I'll pause here in case you want to pause the video and try these questions if you are just viewing this without the document or printed out. And so once you're done those, here, I'll maybe stop it here. There's a next set of questions, so you can pause the video there and try those questions if you'd like. And here are the answers. If you would like to check for answers to those questions, then you may. And that is it for this section.